Have you ever wondered how our planet came to be? How did Earth form from a cloud of dust and gas around the Sun more than 4 billion years ago? And how did life emerge from the primordial soup of chemicals that covered its surface? Hello and welcome to Curiosity, where we explore fascinating and interesting topics about everything. Today we are going to talk about something that might sound like science fiction, but is actually very real and very important: asteroid dust. What is it, where does it come from, and why does it matter? Let's embark on a journey across the solar system and beyond to discover the secrets of asteroid dust and how it could reveal the origins of life. Those are some of the biggest mysteries in science, and they have fascinated humans for centuries. But what if I told you that the answers might lie in some tiny specks of rock and dust that came from outer space? That's right, I'm talking about asteroids. Asteroids are small rocky bodies that orbit the Sun, mostly between Mars and Jupiter. They are remnants of the early solar system, when planets were still forming from collisions and accretions of smaller objects. Some of them are as big as mountains, while others are as small as pebbles. But they all have something in common. They are ancient time capsules that preserve the original materials and conditions of the solar system. And that's why scientists are so interested in studying them. By analyzing their composition, structure, and history, we can learn more about how our own planet and its neighbors evolved over time. And not only that, but we can also learn more about how life originated and spread throughout the solar system. How? Well, because some asteroids contain organic molecules and water, two essential ingredients for life as we know it. But how do we know that? How can we study something that is millions of miles away from us? There are two ways. One is to observe them from afar using telescopes and spacecrafts, and the other is to bring them closer to us by collecting samples and bringing them back to Earth. And that's exactly what two ambitious space missions have done in recent years: NASA's OSIRIS-REx mission and Japan's Hayabusa 2 mission. Both missions launched in 2016 with the same goal: to visit a near-Earth asteroid, land on its surface, grab some material, and return it to Earth for analysis. But they chose different targets. OSIRIS-REx went to Bennu, a dark and rugged asteroid about half a kilometer across, while Hayabusa 2 went to Ryugu, a slightly larger but similar asteroid. Both asteroids are classified as C-type or carbonaceous asteroids, meaning they are rich in carbon and other organic compounds. The missions were not easy. Both spacecrafts had to travel for several years to reach their destinations, then orbit them for months to map their terrain and select a suitable landing site. Then they had to perform a delicate maneuver to touch down on the asteroid's surface for a few seconds, while firing a projectile or a gas jet to stir up some dust and rocks into a collector device. Then they had to take off again and store the samples safely for the return trip. But they were successful. Both missions managed to collect more material than expected. OSIRIS-REx got about 250 grams of pebbles and dust from Bennu, while Hayabusa 2 got about 5 grams of grains and fragments from Ryugu. And both missions managed to deliver their precious cargo back to Earth. Hayabusa 2 in December 2020 and OSIRIS-REx in September 2023. And now comes the exciting part: opening the containers and analyzing the samples. Scientists have been eagerly waiting for this moment for years, hoping to find clues about the origin of life in these ancient rocks. And they have not been disappointed. The first results have been incredible. For example, scientists have found evidence of both water and organics in both samples. Water is not liquid on asteroids, but bound to minerals as hydrated crystals. Organics are molecules that contain carbon atoms bonded to other elements like hydrogen, oxygen, nitrogen, or sulfur. These molecules can range from simple ones like methane or amino acids to complex ones like proteins or DNA. According to Ars Technica, scientists have found that the samples from Bennu contain fibrous clay particles that have water locked inside them. They have also found carbon-bearing minerals and organic molecules that are similar to those found in meteorites that have fallen on Earth. These findings suggest that Bennu is a remnant of a larger parent body that was once wet and had complex chemistry. Similarly, according to internet site Fizz, scientists have found that the samples from Ryugu contain organic material that shows some of the building blocks of life on Earth may have been formed in space. They have also found traces of minerals that indicate that Ryugu was exposed to high temperatures and pressures in the past, possibly due to impacts or collisions with other bodies. These findings are amazing because they show that asteroids are not just inert rocks, but dynamic and diverse worlds that have undergone physical and chemical changes over time. They also show that asteroids are sources of water and organics, which are essential for life. But how did these materials get to Earth? Well, one possible way is through asteroid impacts. Throughout its history, Earth has been bombarded by countless asteroids of different sizes and types. Some of them were large enough to cause mass extinctions, like the one that wiped out the dinosaurs 66 million years ago. But others were smaller and more frequent, and may have delivered water and organics to the early Earth, when it was still hot and dry. According to NASA, some scientists estimate that about 70% of Earth's surface water came from asteroids and comets that hit the planet during its formation. And some scientists also speculate that some of the organic molecules that are the building blocks of life, such as amino acids or nucleotides, may have also come from asteroids and comets or may have been synthesized on Earth using asteroid-derived materials. Of course, this does not mean that life itself came from asteroids. Life is much more than just water and organics. It requires a complex set of conditions and processes that are still not fully understood. But it does mean that asteroids may have played a role in creating the environment and the ingredients for life to emerge and evolve on Earth. And not only on Earth, but possibly on other planets as well. Asteroids are not exclusive to our solar system. They are found in other star systems as well, orbiting other suns. And some of them may also contain water and organics, and may also impact other planets that could potentially host life. In fact, some scientists think that life on Earth may have originated elsewhere in the galaxy and was transferred to our planet by asteroids or comets carrying microbes or spores. This is known as the panspermia hypothesis, and it is one of the many possibilities that scientists are exploring to explain the origin and distribution of life in the universe. But to test these hypotheses, we need more data. We need more samples from more asteroids and from other celestial bodies as well, such as comets, moons, or planets. We need more missions like OSIRIS-REx and Hayabusa 2, or even more ambitious ones like sending humans or robots to explore and mine asteroids. We need more curiosity and more imagination to ask new questions and find new answers. Today we learned about asteroid dust, how it could reveal the origins of life on Earth and beyond, and how scientists are studying it using amazing space missions. We hope you enjoyed this episode and learned something new and exciting. That's all for today's episode. Thank you for watching Curiosity. If you enjoyed this video, please like and subscribe for more content like this. And don't forget to share your thoughts and questions in the comments below. Until next time, stay curious.